Hello friends, welcome to my channel Academic Made Easy PC. If you have not subscribed my channel, subscribe it and also click the bell icon. In this video, we will be learning Chapter 2 Polynomials of Class 10. In this chapter, we will be learning about polynomials, degree of polynomials, zeros of polynomials, etc. And also we will be learning about linear, cubic, quadratic polynomials also. And till now, we have learnt divisions of numbers. In this chapter, we will be learning division of polynomials. So that's really interesting. And this chapter is interesting as well as very easy chapter. So now let's move on. First, let me give you all the definition of the polynomial. Any expression of this form is called a polynomial of degree n in variable x, where a not equal to 0, where n is a non-negative integer, and a naught, a1, a2, etc. an are real numbers, called the coefficient of the terms of the polynomial. See, it's nothing but this is the expression. This will be the expression. So, for example, if we just take ax cube plus bx square plus cx plus d. This is the expression that I took. So this will be a0, a1, a2, a3. Just like that it will be going on. And here it is a0, isn't it? So a0 means x power n it is given. So x power 3. So next if I take this as a1, so x power n minus 1. So here what is my n here? 3. 3 minus 1 is 2. That only is given in the general form. So this is the general form for any polynomial. So next they are saying that this a0, a1, a2, everything is a coefficient of the x. Okay, so then this will be the constant term since it does not have any x. So we already have learnt about coefficient of x and all, isn't it? So that will be easy for us. And now let's move on. A polynomial of x can be denoted by the symbols p of x, q of x, f of x and g of x. See, if x is over here in the function, then it means the function is on x. Okay, so this will have some real numbers in the x. Next topic is degree of the polynomial. So degree of the polynomial is nothing but what type of polynomial it is. It is whether linear or quadratic or cubic. That only is degree of polynomial. Degree of polynomial is nothing but the highest power of the polynomial. That is, if p of x is a polynomial in x, the highest power of x in p of x is called the degree of polynomial. So for example, I have given here, see, 5x cube minus 4x square plus 2x plus 2. This is the polynomial p of x. Okay, so since the function is on x here. Okay, so now how will I find the degree of the polynomial here is that I will be checking the powers of x alone, not any other power, only the power of x. So here x power is 3, here it is 2, here it is 1. So x is nothing but x power 1. No, so yeah, in this which is very high, that is the highest power, 3, isn't it? So the degree of the polynomial here, it is 3. And one more example. So this is our p of x. Next, p of x. So now x square plus 2x plus 3. This is the p of x given. And we have to find the degree of this polynomial. So now I will be checking the degree of x alone, not any other degree. So I have 2 and 1. Which is highest power? 2. 2 is highest, isn't it? That is 2 is greater than 1. No? So therefore the degree will be 2. That's it. Next, we will be learning about linear, quadratic and cubic polynomial. So first, linear polynomial means the highest degree will be 1. Then it is called linear. Linear means what? 1, isn't it? So that is what linear. So a polynomial of degree 1 is called a linear polynomial. So here the highest degree, if you check only one x is there, that is 1. The power of that x is 1. Over here also it is 1, here also it is 1 only. So this is called a linear polynomial. And one more important thing is that we will be having only one zero for linear polynomial. I'll just teach you what is a zero of the polynomial. Then quadratic polynomial. A polynomial of degree 2 is called the quadratic polynomial. If the highest degree of a polynomial is 2, then it is called a quadratic polynomial. So 2x square plus 3x plus 4. Here the highest degree is 2. So therefore it is called a quadratic polynomial. So even if x square minus 2 is given, then the highest power is 2 only, no? So then it is called a quadratic polynomial. Next, cubic polynomial. A polynomial of degree 3. So here it should be 3. That is called a cubic polynomial. So if you just check here, 4x cube plus 3x square minus 2x plus 1. So this is the cubic polynomial because the highest degree here is 3. The next interesting and important topic is that zeros of the polynomial. So zeros of the polynomial is nothing but the solution for the given polynomial, whether it is linear or cubic or quadratic, whatever it is, finding the solution of the given polynomial is called zeros of polynomial. So the zeros of the polynomial in x, that is p of x, are precisely the x coordinates of the points where the graph of y is equal to p of x intersects the x-axis. So now it is nothing but, for example, if I have x minus 2 is equal to 0. So I will be finding x is equal to 2. So this is the zero of the polynomial. Okay, so now next if I go with quadratic polynomials, so I have x square minus 4 is equal to 0. So x square is equal to plus 4, isn't it? So x is equal to plus or minus 2. This is my answer, isn't it? So therefore I will say that this is the zero of the polynomial, plus 2 and minus 2. So these are the zeros of the polynomial I will be saying there. Okay. So now this graph is here, this is called a parabolas. So from this graph also we will be finding the zeros of the polynomial. How means, if p of x is given, then the function is based on x only. So we will be taking only the values of x, not y and all those. So now we will be checking at what point x is meeting over here. So for this graph where and all x is meeting, let's check. So here it is meeting, isn't it? So next over here, only 2 places it is meeting. So therefore this polynomial, we don't know what, I just gave you a graph for example. So in this graph we have 2 zeros of the polynomial. Okay. So for 0 of the linear polynomial will be is equal to constant term divided by coefficient of x of x. So this will be negative, minus constant divided by coefficient of x. So the next topic is one of the important topic, that is relationship between zeros and coefficient of a polynomial. So I already taught you what is zero of a linear polynomial, isn't it? That is a relation between zeros and coefficient. Okay. So now let's see for quadratic and cubic polynomials. First, let us see for quadratic polynomial. If alpha and beta are the zeros of the quadratic polynomial, in the example I just gave, no, 2 and minus 2. So that were the zeros of the polynomial. So this will be taken as alpha, this will be taken as beta, just like that. So any zero can be taken as alpha and beta. So alpha and beta are the zeros of the quadratic polynomial ax square plus bx plus c. Then we have two relations, okay, so that is sum of zeros and product of zeros. So if we take sum of zeros minus coefficient of x divided by coefficient of x square, that is a sum, that will give us the sum of zeros. So for example, see, so here alpha plus beta is equal to minus b by a. So this is the general form, isn't it? So the coefficient of x is over here and coefficient of x square is here, the denominator. So negative of that will give us the sum of the zeros. Now we will be learning about product of zeros. So alpha and beta are some zeros. So what will be the product is that constant term divided by the coefficient of x square. So alpha into beta is equal to c divided by a. And this too is very important, where we may get for 2 or 4 marks. Sure question. So now let's learn for cubic polynomial. So if alpha, beta and gamma, these symbols represents alpha, beta, gamma, are the zeros of the polynomial, cubic polynomial, that is ax cube plus bx square plus cx plus d. This is the general form for cubic polynomial. Then alpha plus beta plus gamma is equal to minus b by a. So as we did for quadratic equation, that is quadratic polynomial, we just did with alpha plus beta. Here one extra thing will be there, that is alpha beta plus gamma. So that will be minus b by a, as it is for quadratic as well as cubic and for linear also. For these three, if we take the sum of the zeros, then we will be getting minus b by a only. Okay, so next we will be learning the sum of products. Sum of products is nothing but alpha beta, beta gamma, gamma alpha. That is the sum of products. So that will be c by a. So there, for a quadratic equation or polynomial, we just saw c by a. No, when it is alpha beta alone, and here if it is alpha beta plus beta gamma plus gamma alpha, then it will be c by a. So just have it in mind that for every, that is sum of products or sum of zeros, the denominator will be a only, that is the coefficient of x cube, that is highest power. If it is for quadratic polynomial, it will be a square, that is the coefficient of a x square. Then here it will be x cube. So then products alone, that is alpha, beta, gamma is equal to minus d by a. So this one you have to know. Next topic is division algorithm for polynomials. This is one of the very interesting topic and a tricky topic in this chapter. So we have to know the formula. If we know the formula, it will be easy for us to do. So if p of x and g of x are two polynomials with g of x not equal to 0, then we can find polynomial q of x and r of x such that, see, it is nothing but it is division. So it will be given like p of x divided by q of x, or p of x comma q of x will be given, and we have to find the division of g of x. G of x will be given and we will be finding the division. So here, so the divisor always will be g of x and the dividend will be p of x. Okay, so we will be dividing these two, and the q of x will be the quotient and the r of x will be the remainder. Okay, so p of x is equal to g of x into q of x plus r of x, that is dividend is equal to divisor into quotient plus remainder. So this is the formula that we will be using in order to find the division algorithm of polynomials. So here r of x will be equal to 0, or else the r of x will be less than the degree of g of x. So r of x degree will not be greater than the degree of g of x. That's it. So with this, introduction part is over. If you have any doubts, mention it in the comment box.
Like, comment, share, and subscribe.